In module 1 we expect to complete analysis of stress, and module 1 will have around 6 lessons, including the lesson which we will be discussing today, wherein we will be introducing the concept of the stress. Module 2 will have around 8 lessons which will be on analysis of strain. Module 3, which is the application of stress and strain, which is on thin wall pressure vessels, will have around 3 lessons. Module 4 is on torsion, which also will have lessons 4 lessons in this particular module. Module 5, which is on bending of beams, also will have 4 lessons. Module 6, which is on stresses in beams, will have also 4 lessons. Module 7 on deflection of beams will have 4 lessons. Module 8, which are on combined stresses, will have 3 lessons, and module 9, which is on stability of columns, will have 2 lessons, and module 10 on springs will have 2 lessons. So, thereby in these 10 modules we expect to cover around 40 lessons, in which the entire aspect of, or the basic aspect of, strength of material is going to be covered. Now, this particular course, the engineering mechanics, as we know, basically has 3 fundamental areas, and they are the statics, dynamics, and the mechanics of material. Now, it is expected that you have already gone through the aspects of statics and dynamics, and as you have noticed probably that statics and dynamics mainly concerns with the study of external effects on rigid bodies, and there we do not consider the deformation of the bodies, or the deformation of the bodies are neglected. Whereas, in mechanics of materials we deal with the studies of bodies which are subjected to externally applied loads, and we look into the aspects of the internal effects of such of the loads which are acting externally, and the deformation characteristics of the structural member. So, in mechanics of materials we are interested with these 2 aspects, the internal effects of the externally applied loads and the deformations that are caused within the body because of the externally applied loads. And in fact, both the aspects of this internal information of the load and the deformation play an important role while designing a member. In fact, we look into what we really mean by design. When we try to arrive at a particular size of a member, we need to know that how it deforms, or what is the effect of the external load on that member internally, and these are the aspects are dealt in the subject which we call as mechanics of materials. Now, mechanics of materials, in fact, if you look into, you will find that they are called in different names. They may be called as strength of materials, or mechanics of deformable bodies, or mechanics of solids. Now, whatever name we may call the subject as, basically they contain the same information, or they give you the similar information, whether it is mechanics of materials, or strength of materials, or mechanics of deformable bodies, or mechanics of solids, they mean the same thing. Now, here we have termed this particular subject as strength of material. Now, it is interesting that all branches of engineering, they deal with some kind of physical systems, and these physical systems are composed of the individual parts. If we look into different systems from different engineering disciplines, you will find these physical systems, they compose of different elements, and each individual elements, when they are connected together, they give the whole system. Now, these systems, or the individual units, are to be defined or assigned a definite physical size, and these elements are fabricated from some materials, and we need to know the character of these materials, the behavior of these materials, so that the whole structural system or the whole physical system, which is made up of different elements, can withstand the external load, and that is what is the objective of this particular subject, wherein we look into that these elements, what are the different kinds of forces they are subjected to, and what are the behaviors of these elements against these external loads. Now, if we talk about a building structure, which you must have noticed in several places, that this particular building structure is made of some kind of material. Also, this particular building structure is made of some individual elements, and all these elements, when they are combined together, they give this building structural form. Now, it is expected that this particular building structure should perform some of the functions for which it has been built or it has been designed. Now, the functions like that this particular structure is subjected to different kinds of loadings, and these loadings could be generated from the environmental aspects, such as for the effect of wind on the structure, or this particular structure may be subjected to earthquake forces. Now, apart from these loadings which are expected to come on this building from the environmental or the surrounding environments, they are also subjected to some kinds of loads, say for example, its own weight of the element. There could be loads where human being will be moving around, there could be loads which are arising up because of some operation of some equipments inside the building. So, this building structure as a whole and individual components based on combining which we have formed this whole structure, they are subjected to these external loads. Now, we will have to know, or we will have to find out that what are the effects of these external loads on the building structure as a whole, and in the individual units in parts, that what are the effects of these loads. Now, it may so happen that the flow of the building on which people are moving, now if it deforms excessively, then there is a possibility that it may not be in a usable form, and as a result it is not in a serviceable condition. So, we will have to know that whether the elements with which this whole structure is built, whether they can withstand the external loads which just we talked about, whether it can perform, that it does not have excessive deformation, whether the whole structure is stable in its form, that because of such environmental loading, because of huge loading or wind loading or earthquake, whether the whole structure will be in a stable position or not. Now, these are the answers we like to find out, and the area which covers this is nothing but the strength of material. Now, other than this building structure, this interesting structure is a bridge structure, which is bridging the gap between the two sides, two ends of this river. Now, as we have seen that in case of building structure, we have loading from the environment, which we have said for the wind or the earthquake. Now, this particular structure, apart from those loading, it will be subjected to loads because of the movement of the water. The supporting structure which is holding this bridge will have the loads because of the movement of water. So, that is an additional load which is coming on this structure. Also, there will be vehicular movement on this particular supporting structure, that also will impart load on this particular structural form. And as you can see, that whole bridge structure should withstand these loads without undergoing the excessive deformation, or the strength of this structure should be such that it can withstand these external loads. Also, as you can see that this particular structure is composed of different elements. So, individually these elements should be in a position to withstand all these loads. So, again what I like to emphasize is that a structure, when we consider, they are fabricated or constructed out of individual elements, combining them together. So, each individual elements will be subjected to some kinds of forces which we will be looking into as we progress in the course, and those members should be in a position to withstand those forces safely without causing any failure of those elements, because if any individual element fails, that may lead to the failure of the whole structure. Now, let us look into the other areas, say for example, a spacecraft structure. These also are subjected to different kinds of environmental loading, apart from the loading which will be generated for the movement of the spacecraft, and the structural body is made up of some material which should withstand the forces that it is subjected to, and also one of the requirements of this spacecraft is that that material which we use or the whole structural body should be lighter in nature. Now, if we have to adhere to this particular condition, that means we need to look into a particular type of material which can withstand safely the forces that will be generated in this particular structural form. At the same time, it should not contribute to the much weight to the structural form, and or in one word, the whole structure should be stable, it should be strong to withstand the external forces, and also it should not have excessive deformations in different positions. If we look into this particular mechanical equipment which is used for testing purposes, now this mechanical equipment have several parts. When the loads are applied to the specimen for testing, these equipment parts are also subjected to some kinds of loading. Now, these individual parts are to be assigned size in such a way that they do not undergo excessive loading, or in other words that the loads distribution should be such, the parts sizes should be such that it can withstand the load which is coming because when it is in operation. So, you see, whether it is a building structure or a bridge structure, or you talk about spacecraft, or you talk about the mechanical components, even the electronic engineers, when they use the printed circuit boards wherein the chips are mounted, the boards are to be strong enough to withstand any environmental loading that is coming on that. It should be positioned properly in the support, it should not fail. So, you see, any physical system used by any engineering discipline, they should be such that they can withstand the external loads coming on such structural forms. So, our objective is to analyze these individual parts with which all these structural forms are used. Structural forms in general, it could be building structures, it could be bridge structures, it could be spacecraft, it could be mechanical components. So, any of these structures, when they are built with these individual components, now these individual components are to be analyzed and see that whether they satisfy the strength requirement, they satisfy the deformation requirement, they satisfy the stability requirement, and this is what we look for in this particular subject, strength of material. So, as we have discussed that appropriate sizing is necessary for these parts to safely withstand the imposed forces and at an optimal cost. Though we are not going to talk much about this cost aspect of it, but when we talk about the term design, we are concerned with both the safety and the cost. When we say safety, we mean that the elements should be assigned the sizes in such a way that it can withstand the external loads, and these external loads could arise from any of such conditions as we have discussed, and many a times it may so happen that we give a larger size for a small a particular element, and thereby we satisfy the strength or deformation requirement. But it may so happen that a smaller size of that could easily withstand that force without causing much of harm in terms of strength or deformation. Naturally, then the smaller size will be more economical than the larger size which we go for, though both are safe in terms of strength and stability and deformation. Hence, what we need to do is that not only we should look into this strength, stability and the deformation characteristics, but we should look into the cost aspect as well when we talk about the proper design, and that is what is the job of the designer, Well, for the time being we will not look into the cost aspect of it, but we will be more concerned with the aspects on strength, we will be more concerned with the aspect on the deformation and the aspect with the stability, and that is what we will be looking into in this particular course. Hence, it is essential to study the behavior of material from the strength and deformation point of view, as well as the characterization of different kinds of forces which cause different types of stresses in the material. In fact, in few minutes we will look into what we really mean by stress. So, we are concerned about the strength, the deformation, and of course, we will like to look into the effects of different kinds of forces that this particular member will be subjected to, that can cause different kinds of stresses in the material. Now, the subject which deals with the analytical deformation of the strength, the deformation characteristics which we call as stiffness, and stability of different members is normally designated as strength of materials. So, you see again I emphasize that we like to look into these three aspects. One is strength, another is stiffness, which is nothing but the deformation characteristics of the members, and the stability of different elements which we look into in this particular course, and which are the combinations of on all these three. That means, the characterization of strength, the deformation, the stiffness, and the stability, all we look into in this particular course, which we normally call as the strength of material. Now, so we are in fact in strength of material, we are interested in these three characteristics. One is strength, another is stiffness, another is stability, and these are called as 3 S's of strength of material. So, we are concerned with the 3 S parameters, the strength, the stiffness, and the stability. Well, now having looked into this background of the strength of material, let us look into a little historical background of this particular course. In fact, the strength of material is quite an old subject. In the earlier part of the 17th century, in fact Galileo or Leonardo da Vinci, they tried to give a rational meaning of these aspects of structural members. Prior to that, in fact, people used to use these concepts which were based on the experience and mainly based on the rule of the thumbs. But Galileo started giving explanation in a more rational way onto the different aspects of the forces in the bars in terms of tension, in terms of compression, and of course, Galileo emphasized more on the experimental side of these elemental characteristics. In fact, the strength of materials in that sense is a fascinating blend of both the experiment and the theoretical aspects. In fact, Leonhard Euler in 1744, he gave his theory on the column buckling. Now, he had explained that how do we arrive at the critical buckling load for a column member, but since he did not have any experimental evidence, in fact it took almost 100 years to establish or re-establish this particular theory of Euler's. Still today we talk about the Euler's column buckling aspects. So, in fact, in the earlier stages we had lot of theoretical explanations, we had experimental evidences, but subsequently the French investigators like to name a few, Cauchy, Navier, Poisson, Coulomb, Saint Venant and several others, they had devoted their attention on these areas, the theoretical development of the strength of materials aspects or the mechanics of material aspects, and based on which we find that this particular subject where it stands today is based on their research investigations, and several theories came up based on their research findings. Well, then with this background, what we expect from this particular course is that once this particular course is completed, that means once somebody goes through all these lecture lessons of 10 modules, it is expected that one should be in a position to understand the classification of different kinds of forces that structural components are subjected to. Now, when we say structural components, the structural component we talk in a generalized term, it is not that of any particular structure. The structure could be a building structure, it could be a bridge structure, it could be a structural component of any mechanical equipment, or it could be a part of any spacecraft, or any structural form we talk about. It is a part, any part of this structural system as a whole, any part when they are subjected to different kinds of forces, we should be in a position to characterize those forces, we should be in a position to find out the effects of the forces on such structural component. So, the classification of different kinds of forces that structural components are subjected to. Now, effects of different forces on such components and their solution techniques, this is what we will be looking into in this particular course. Now, different types of stresses and deformations that develop due to forces. So, one is the classification of the forces that the structural components will be subjected to, then effects of those forces on these components, and subsequently the different types of stresses and deformations that these members will be subjected to, we will be analyzing them systematically. Hence, the scope of this particular course includes the identification of different types of forces that the structural components will be subjected to, and as we will go along in this particular course, you will find that in different modules we have looked into the different types of forces these structural components are subjected to, and how to analyze those forces or the components of the forces that will be the members will be subjected to, and how to compute the stresses in the members based on those forces. Also, we will look into the systematic evaluation of the effects of these forces on such structural components. Well, we will be confining ourselves to the material which are useful for engineering application. This is important that we are not going to cover the whole lot of material, because when we talk about the material, it is quite general in nature, it covers many aspects or different kinds of materials, but here we will be restricting ourselves to the materials which are useful for engineering application, and that is what should keep in mind. Also, the structural members which we talk about, they do follow the laws of Newtonian mechanics, and this following the laws of Newtonian mechanics, thereby the equilibrium of forces which are governed by this mechanics law, that will be enforced. Also, it will be essential to know the mechanical characteristics of the material with which the member will be fabricated. So, you see here when we talk about these aspects, we will be dealing with, one is the theoretical aspect, where we will be looking into the equilibrium of forces, the forces which are acting on the body, and if we try to equilibrate with the internal forces, so governing the Newton's laws of mechanics, that will be adopted. Subsequently, we will have to use the mechanical behavior of the material with which these structural elements will be fabricated. Now, to characterize this behavior of this material or the mechanics of that material, we need to adopt some kind of experimental investigation. So, this part will have the output from some test results in the laboratory. So, you see that it will be a combination of the theoretical aspects along with the experimental investigations, and in the strength of materials, in fact, is a blend of these two, the theoretical aspects on which we apply the laws of Newtonian mechanics, and we try to characterize or we take the behavior of the material based on some experimental evidences. So, the combinations of these two will lead us, different theories will lead us to the evaluation of stresses due to the externally applied load on such structural members. Well, as you will go along, you will find that the whole course will be dividing broadly in two parts. One is the logical development of the concept, and another one is the application of these concepts to the practical problems. Now, when we talk about the logical development of the concept, basically based on these concepts we will try to derive the formulae that are necessary for arriving at different kinds of stresses in the member for the external loads, and that is what we will be looking into. The first part will be devoted on that, or for any lesson initial part will be devoted on the derivations of the theoretical background or the concept, and based on that particular concept or the formulae so arrived, we will be looking into some application problem areas or the example problems, and in those application concepts you will find for the problems we classify into two groups. One we call as the numerical problems, other one are the algebraic problems. Now, when we talk about the numerical problems, it means that we will be dealing with some example problems in which we will be assigning some specific values, whereas in case of algebraic problems we will try to arrive at in some expressions which are very general in nature. Now, both are having its merits. When we talk about the numerical examples, now at each step of these examples when we will be evaluating it, we can visualize based on the values of each parameter we will be arriving at, and then we can get a feel of those parameters physically, what they represent and what they should be and what actually we are getting. Now, when we talk about the algebraic problem, there we will be discussing about the problems which could be general in nature, and thereby we will arrive at certain expressions, and on those expressions or these expressions can be used for solving specific problems where we will have the specific numerical value for some parameters. So, this is how we classify the two groups of problems. So, this is what is indicated over here, that the application concept which we derived in the initial stage, these concepts when they are applied to the practical problems, they could be applied to the numerical problems or it could be to the algebraic problem, and as we go along in the lesson we will find, or as we go along in the different modules, we will find that we have taken different examples from different areas which satisfy the requirement of different engineering discipline, or those structural components they can be used for arriving at or for characterizing the behavior of those individual elements, so that they can be used according to the need of any structural system. Well, now when we talk about that numerical problems or the application problems, we talk about the units and the basic units which are used. Now, we use the international system of units in this particular course, and the basic units for this international system, this meter is for length, let us call this length as L, kilogram or abbreviated form is kg, that is for mass m, and for time we use second or in abbreviated form as s for time, which let us call this time as t. So, based on these basic units L for L, m and t, we arrive at certain derived units. Now, when we talk about the units for the area, area as we know is the product of two linear parameters. So, let us call L is in meter multiplied by length in meter, and thereby we will get the unit of area as meter square. Now, if we talk about the unit for velocity, which is distance by time, so L by t, and if we substitute the units for these basic parameters, they are meter per second. If we talk about the units for acceleration, which is rate of change of velocity. So, this is L by t square, and thereby it gives the unit as meter per second square. Now, once you know the acceleration, then the force term P, this is equals to mass, which we have the basic units of which is kg, times acceleration, and the, as we have seen, the units for acceleration is meter per second square. So, this gives us the unit kg meter per second square. Now, this unit kg meter per second square we normally designate as Newton, and the abbreviated form of Newton is N. Thereby, when we talk about the unit of force, it is in Newton. Now, for higher values we use different parameters. We can call this in kilonewton, which is 10 to the power 3 times Newton. We define in meganewton, which is 10 to the power 6 times Newton. Also, many a times we use parameters, as we have seen, then the force we are defining in Newton, and it could be in kilonewton or meganewton, which is 10 to the power 3 Newton or 10 to the power 6 Newton. Now, we define another parameter which we call as stress, which we will be looking into in few minutes. This units for stress, or the stress we define as the force per unit area. So, the unit of force, as we have seen, is Newton and area is meter square. So, the unit for the stress we call in Newton per meter square, and this is called as Pascal, Pa. And since 1 Newton of load, when it is acting on 1 meter square of area, in fact this amount comes quite small, because 1 Newton load is very small, whereas meter square area is very large. So, many times these stresses we represent in terms of megapascals or kilopascals. Now, when we talk about kilopascals, this is, as we have designated that load Newton as kilonewton, kilopascals will be 10 to the power 3 times Pascal, megapascal will be 10 to the power 6 times Pascal. Now, so instead of defining in terms of area in terms of meter, many a times what we do is we define in terms of millimeter. So, if we have the stress in 1 Newton per millimeter square, then this is equals to, if I convert this millimeter into meter, then it is 10 to the power 6 to Newton per meter square. And as we have seen that Newton per meter square is 1 Pascal, so this is 10 to the power 6 to Pascal. Now, 10 to the power 6 Pascal, as we have seen, this is megapascal, so this is nothing but equals to 1 megapascal. So, we can say that 1 megapascal is equals to 1 Newton per millimeter square. Also, many times we use the unit called gigapascal, which is 10 to the power 9 times Pascal. So, 10 to the power 9 into Newton per meter square, as Newton per meter square is the 1 Pascal unit. So, the stresses can be represented either in terms of Pascal or kilopascal or in megapascal or gigapascal. So, as you can see, then based on these basic units as we use in international system, that your length in meter, the mass in kg and time in second, based on those basic units we can arrive at the derived units, and as we look into in this particular course we will be more concerned with these units on stresses, which is Pascal, and thereby we will come across many places the Pascal, kilopascal, megapascal or gigapascal for the units of the stresses. Well, having known then the units, let us look into some aspects of the forces that the body I mean a member is subjected to. Now, we come across a term which we call as a body force. Now, body force basically is associated with the units of volume of the body, and thereby it is basically a distributed system, the force which is distributed over the entire volume of the body, and in that sense the gravitational force or the inertial force or the magnetic force, these are the forces which we term as the body forces. Now, though it is distributed over the volume, when we try to analyze the forcing system, the body force we apply assuming that it acts through the center of gravity of the body. So, when we analyze a particular component, a structural component, the body force we apply at the center of gravity of the body, and basically these are the forces, the gravitational force or the inertia force or the magnetic force, they are generally termed as the body force. Now, having known the body force, we are interested to know about the surface forces. Now, there is another kind of force which acts on the body, which we call as surface force, and from the name itself you can make out that these forces act on the surface of the body, or we call these are the area elements of the body. Now, these forces on the surface, supposing this is a structural body wherein we have two kinds of support, the body is supported or constrained at these points and subjected to the forces at these points. Now, these forces which we call as a concentrated load at this point, that means on this particular surface of this body, this particular force is acting, and it is over a very small area, and thereby there is a force concentration at that particular point. So, with that particular load or the force we call as a concentrated force. It could be distributed also over some area, like in this particular case if you look into that, it is distributed on this particular area, surface area of this particular element, and these we call as the distributed force system. So, a body on the surface, they could be subjected to either a concentrated force or could be a distributed force. Now, when these surface forces act on the boundary, we call that as a surface traction. So, please keep in mind that the surface forces could be a concentrated force or it could be a distributed force, and when these forcing system they act on the boundary, we call that as surface traction. Now, having known the body force and the surface force, another aspect with which we will be dealing with quite frequently and we should be concerned with is about the internal force. Now, to know the internal force, we will have to look into one aspect which we call as a free body diagram. Now, let us consider a body which is supported at these 2 points and subjected to these 2 loads P1 and P2, and these we call as external loads. So, the external loads are acting on this particular body. Now, since this particular body is in equilibrium, so under the actions of these external loads, now there will be some amount of reactive forces generated at these support points. So, if we remove these supports from this body and represent the body in this form, where P1 and P2 are the forces which are acting on the body, which we call as a active force, and because of these active forces on the supports there are reactive forces which are R1 and R2. Now, these active and reactive forces of P1, P2, R1, R2 keeping this particular body in equilibrium, and hence when we consider or when we represent a body with the external loads, in fact these reactive forces are also external loads, but when we represent the whole body, when we make them free from these supports, and represent them using the active force and the reactive force, this particular diagram we call as a free body diagram. So, this is the free body diagram of the structure as a whole. That means, we have freed this particular structure from its supporting constraint and applied the reactive forces over there. Now, supposing if I like to cut this particular body through a plane and define and break it into two halves, then if this particular structure is cut through the plane and divided into two halves, then what we get? Then we get a form something like this, wherein you see that this particular half of the body is subjected to these external loads P1 and P2. Now, since the whole body is in equilibrium, hence the parts of the body also should be in equilibrium. Now, when we have taken a cut of the body and separated it out in two halves, and as we can see that internally there are some forces which will be generated, which we have called as S1, S2 and S3, and the other half also will have the reactive forces, and these forces of course will be equal and opposite in nature, because in statical form they are in equilibrium conditions. Now, these forces which are generated internally to equilibrate these external loads, we call these forces as internal forces, and these diagrams also are called as free body diagram. So, as you can see that to obtain a free body diagram, we can remove the reactive constraints and make the body free from the supports, and thereby we draw all the external loads acting on that. That is also a free body diagram. Or we cut the body and make different parts, and on that we show the external force and the internal force, and that is also a free body diagram. Now, this free body diagram gives us the idea of the internal forces. Now, in mechanics of materials or in strength of materials, what we are concerned with is these internal forces or the intensity of the forces which are acting. Now, as you have seen, these internal forces equilibrate the external forces and keep the body in equilibrium. Hence, what we are interested to find out is the intensity of these forces and how they keep the body in equilibrium and thereby resist the deformation of the whole structure. Now, if we look into this particular body, wherein we have taken a cut, and this cut is if we take the normal to this cut, it directs along the x axis. Now, on this we have a small force delta P acting a small area which is delta A. Now, it is customary now to decompose this force in two directions. One is in the perpendicular to the cross section and another one is along the plane of the cross section. Now, if we do that, if we decompose this load perpendicular to the section which is del Px, because it is in the direction of x, and further in the plane the load which is parallel to the plane can be decomposed in two directions. One is del Py, another is del Pz. Now, since we are interested in the intensity of this force over this area, so del P by del A gives us the intensity, and that we call as stress. So, stress basically is equals to del P by del A. Now, we have taken the components along x, y and z direction, and mind that we have taken a cut, the perpendicular to that is matching with the x direction. Now, this del Px by del A we call the stress in the x direction, this is tau. Del Py by del A we call this as stress in the y direction, and del Pz by del A we call the stress in the z direction, this should be xz. Now, on a limiting scale, because we are concerned about the stress, when we talk about the stress, it is stress at a point. So, the stress at a point when limit delta A tends to 0, this tau xx, tau xy and tau xz gives us the stress at a particular point. Now, the way we have given these designations, if you look into that, tau is the term for the stress, the first subscript defines the plane. As I said that for the body we have taken a cut, the perpendicular, the normal drawn to this plane directs towards the axis x. So, this we call as x plane, and this particular parameter gives the direction of the stress. So, first one we have tau xx, which indicates that it is the stress in x plane directed towards x, tau x y says the stress in x plane directed towards y, and tau x z says as the stress in x plane directed towards z. Now, when we have the plane and the direction coinciding, or the if this is the direction of the normal to the plane, and stress also is directed towards this we call as the normal stress, and we designate generally with sigma. So, sigma x defines that this particular stress is normal to the plane, and this normal stress could be tensile or compressive in nature. Now, when the pull, when this particular force is perpendicular to the plane and it tries to pull the body, we call that as a tensile, and when it pushes the body, we call that as a compressive stress. We will look into more on this aspect at later lessons. Also, the stresses which are acting in the plane of the cut, we call that as shear stress. So, stresses multiplied by the respective areas on which they act give us the forces, and at sections the vector sum of these forces are known as the stress resultants. And basically, in problem of strength of materials, we are interested to evaluate these stress resultants, and from those stress resultant we compute the values of the stresses in a body which are subjected to different kinds of loads. Now, in this example we are interested to draw the free body diagram for this. Now, this is a bar which is subjected to a tensile pull. Now, if we like to draw the free body diagram of the whole bar, then the free body diagram will be like this, that it is acted on by this force which is through the center of gravity of this particular member. So, the reactive force also will be P, or if we take a cut somewhere, then it will be a small part of the body, and that also will be in equilibrium under the action of this load, and this is the free body of the part of this particular structural form. Also, if we like to draw the free body diagram for this particular structural form, which are bars subjected to this load P. Now, as we have done, we make this particular structural form free from the supports, and thereby we get the reactive forces. They could be in this form, or we can take a cut in this particular structural form, and thereby you get the reactive forces, the active forces, and the member forces. So, this is the free body diagram of this particular part. So, this is how we make the structure free, or the elements free from these supports, or take a cut and draw the forces, which gives us the free body diagram of structures. Hence, to summarize, in this particular lesson we have included a general idea about the scope of the subject. We have discussed the typical application areas that where strength of material can be applied, or what is the scope of this particular subject, what are the different disciplines where we come across the different problems, based on which, or based on the strength of material formulae, where we can get the solutions for such problems. Then concept of different forces. Also, we have looked into the concept of free body diagrams, and thereby the concept of stress. Well, these are the questions set for you, that what are the units of force and stress, what is the definition of normal stress, what is meant by free body diagram, and what are the axioms on which behavior of deformable member subjected to forces depend. Now, look into these questions. If you go through this particular lesson, you should be in a position to answer these questions. We will be discussing about the answers of these questions in the next lesson.